In this video, we'll work through the first half of the Unit 6 review. Identify each line or segment that intersects each circle. So in problem number 1, we're looking for a secant. So a secant is going to intersect the circle twice and it's a line. So it's going to be this guy right here, L. Now chord is a segment and its endpoints are on the circumference of the circle. So in this case, the chord would be FG. Now a tangent's only going to intersect the line or the circle once. And so in this case, line M is going to have just one intersection with this circle. Its point of intersection would be like right here. Let's go ahead and identify this as line M. The diameter is a special type of chord. It goes through the center of the circle, and in this case, that's going to be FG again. And then lastly, a radius. We have two radius identified in this circle. We could say, well, HG is a radius, or we could also identify HF as a radius. In problem number 6, it wants us to find LM. So in order to find LM, we've got to start by finding X first. Well, I can go ahead and set these two segments equal to each other and solve for X. So 4X minus 2 is equal to 3X plus 3. If I subtract 3X on both sides and add 2 to both sides, I'm going to have X is equal to 5. Now, we could have just jumped straight over here. These two are congruent as well, and so we can see that our X value is 5. Now, in order to figure out what LM is, I'm going to plug that 5 in for the X and then evaluate. So 3 times 5 is 15 plus 3 is 18, and that's the length of LM. In number 9, let me go down the list. Number 7. All right, so what we've got here is an inscribed angle. This guy right here, he has the vertex on the circumference of the circle, and we know that the angle is half of the intercepted arc. So the arc in this case is this guy, and that has a measure of 240 degrees. So if I take half of 240, that will give me my angle, which is 120. In problem number 8, we have an inscribed quadrilateral, and it's asking us for the measure of RSP. So from R to S to P. All right, so that would be, it would be subtending this arc right here, this major arc. All right, so let's figure out what that arc is. If I know that from P to S is 90 and from S to R is 60, 90 plus 60 is 150. That is the minor arc. In order to find this major arc, I'll take 360 and subtract 150. And let's see, that's going to give me 210. So this major arc is 210. Let me clean this up just a little bit. All right, so we know that the angle is half of the arc. So this angle that I've highlighted in green is half of this arc, 210. So half of 210 is 105. In number 9, we have another inscribed angle. We can see the vertex is on the circle, and we know the formula for the angle here is half of the arc. So if my arc is 120, I'll just take half of that, and I'm going to get 60 degrees. And number 10, if your inscribed angle subtends a semicircle, so what that's saying is it's going to cut this circle exactly in half. All right, that means this angle is a 90-degree angle. And well, what that means is that the sum of these two is also 90. So 3x plus 17 plus x minus 7 equal 90 degrees. Let's combine our like terms. So if I have 3x's and add one more x, that's 4x. 17 minus 7 is a positive 10. If I subtract 10, I'll have 4x is equal to 80 and divide by 4, so x is equal to 20 in this case. And number 11 says find the measure of the major arc if its central angle is 35. Let's draw a picture. Its central angle is 35. So it's kind of a small angle. I'm going to draw it like this, 35 degrees. That's, oh, and you know what? That's a inscribed angle, not a central angle. So let me start that over. A central angle is going to have its vertex at the center. There we go. This is 35. That means if on a central angle, it equals its arc. So my angle is 35, my arc is 35. But I want to know what the major arc is. The major arc is this guy right here. So I need to take my 360 and subtract 35, and that's going to give me, let's see, 325. Number 12, explain how to find the measure of an angle with the vertex outside the circle. So let me draw a picture here. Here's my circle. My vertex is outside the circle, and it's between two secant lines. Secant lines are going to intersect twice. So it's going to be something like this. This is my angle, x, and I'll go ahead and identify some of these intersections. So let's call this guy A and B, C, and D. All right, so if I want to find this angle x, then I would need to take half of the difference of those arcs. So the first arc is AD, and we say the first arc because that's the larger arc, subtract BC. And we've got to subtract the larger minus the smaller, otherwise we'll get a negative. So that's how you do it. And the last one for this first part, convert 7 pi over 20 to degrees. All right, so if I want to cancel this pi, I know I'm going to need to multiply by 180 over pi. I want my pi's to cancel. So then I can multiply straight across. I could also reduce though. Let's see, I can cancel a 0. And then I can also divide the 2 and the 18 and make a 9. So now all I've got left with is 7 times 9, which is 63 degrees.